Hello students, today we'll be doing the third problem based on variable acceleration. Now the question says that in an Asian Games event of 100-meter run, an athlete accelerates uniformly from the start to his maximum velocity in a distance of 4 meter and runs the remaining distance with that velocity. If the athlete completes the race in 10.4 seconds, determine the first part of it, his initial acceleration. Second part of it says that his maximum velocity. Now, this problem, if I want to represent in the terms of a graphical pattern, then I can represent it this way. Now here let's take that it is velocity graph, and here I'll be taking as, let's take time graph. Velocity unit is meter per second and time unit is second. Now the question says that in an Asian game event of 100 meter, an athlete accelerates uniformly. Accelerates uniformly, when it says, then V and T will be A is equals to dV by dt. So it is accelerating uniformly. It's a straight line in a distance of 4 meter. So it will reach till a distance of 4 meter and runs the remaining distance with that velocity. So whatever will be the velocity here, that velocity will be continued. Okay, let's consider that this is the velocity, which is the maximum velocity it has reached. Here I'm considering it as 0. This is the distance which is covered in t1 second, and the total distance, as it is mentioned in the question, it is 10.4. so from here till here it will be 10.4 minus t1. I hope you understood this part. Let's take this portion as S1 and this portion as S2. Now the question is why I am representing it in the terms of S1 and S2. This is the point where it reaches till 10.4 seconds. Okay, now one thing you might be knowing, that if I'll be representing in the terms of graph, then distance traveled will be equivalent to area under VT graph. Area under VT graph. Now here, if I'll take area of A1, which is your this part, then it is a triangle. So half into the base is T1 into the height, which is V max. Now this area represent equals to distance traveled. So the distance traveled is 4 meter, as it is mentioned here. So in that case, if I'll see, so my T1 will be 4 upon V maximum. This is the one equation. Let's take this as in a first part. Similarly, if I'll go with the next part, which is the next section of the problem. So here it is, let's take A2 is equals to, as it is a rectangle, so it will be 10.4 minus T1 into, it will be the height is V max. So in that case it is 96. Now how come 96? As the question says that the complete run is 100 meter. So if 4 meter is already covered, then the remaining is 96 meter. Whereas this equation, if I'll reframe in this term, then it will be 10.4 minus, here it is, for a second I'll just make a change because it is 4 into 2, that becomes actually 8. It is an 8 upon V max. So here it will be 8 upon V max into V max is equals to 96. With this, if you'll solve it, we'll get V max equals to 10 meter per second. I hope you understood till this one. Now, if this V max is substituted in this equation, so T1 is equals to 8 upon V max, which is V max is substituted here, then T1 equals to 0.8 seconds. Okay, now if the question says that his initial acceleration, now what is an initial acceleration? Let's take a first part of it. Initial acceleration. So initial acceleration is what actually? It's a slope of Vt graph, which we say as A is equals to dV by dt. So it is slope of Vt graph from 0 to 0.8 second. The 0.8 second what we got from here till here. So for that initial acceleration, so A is equals to dV by dt, whereas this dV by dt can be written as Vmax minus V0 upon T1 minus 0. Here Vmax, we got the Vmax value as 10 meter per second. So 10 minus, as the question says, that uniformly from the start to his maximum velocity. Hence, it will be considered as 0 upon 0.8 minus 0. With this, A is equals to 12.5 meter per second square is the initial acceleration what we got. Similarly, if we'll say further a problem, it says his maximum velocity, which you have already determined. What is the maximum velocity? So Vmax is already 10 meter per second. So with this, you are knowing the value of the second part of the question. I hope you understood the question. This question can be done in a graphical pattern as well. We have used it with the help of small graph diagram. Thank you so much.